All right, so this is a lesson on continuous random variables. Now I am eating a piece of candy, so if you hear me eating, I apologize. Okay, and so is continuous, a good example of something that is continuous is time, weight, anything that is measurable when we're talking about decimals. So remember, discrete was like the number of frogs. Everything was an integer, a positive number, a whole number. Continuous is that we have numbers that will have fractions or decimals in them. So let me do a problem that is very similar to what the homework will be for tonight. And let's say that, let's buy pumpkins, because you know I love pumpkins. And so let's just say for the sake of argument that there are large pumpkins and there are small pumpkins, okay? Like the small pumpkin would be the kind that we had, and a large one would be the kind that you would carve a jack-o'-lantern out. Okay, so let's get the mean and the standard deviation. So let's say a large pumpkin is going to be 7.8 pounds, and a small will be 5.4 on average, with a standard deviation here of 1.6, and we'll have the small have a standard deviation of 0.9. Okay, I'm just making these numbers up. So what I'm also going to do is I'm going to find the variance. Okay, so while I'm here, I'm going to find the variance, which is standard deviation squared. So this is going to be 2.56, and this is going to be 0.81. All right? And so let's go find the expected value of, let's say I'm going to get two pumpkins, a large and a small. So the expected value of a large plus a small is the expected value of a large plus the expected value of a small, which is 7.8 plus 5.4. So 7.8 plus 5.4 gives me 13.2. And remember, we need to have units. So let's just say it's pounds, okay? All right, and so now what I'm going to do is I'm going to find standard deviation. So I'm going to erase this. And remember, I'm going to work in variance. So I'm going to say the variance of a large plus a small is equal to the variance of a large plus a variance of a small. So it's going to be 2.56 plus 0.81. So 2.56 plus 0.81 is equal to 3.37. So the standard deviation of a large plus a small is equal to the square root of 3.37. So I take the square root of that number, and I get 1.84, so 1.84, and let's go to pounds again. Remember, standard deviation and mean always have units. All right, so do you see how I did that? All right, so now let's subtract. Okay, and I'm more apt to ask you about subtraction than I am about adding. All right, so now let's find the difference. So the expected value of large minus small is the expected value of large minus the expected value of small, which is 7.8 minus 5.4. So 7.8 minus 5.4 is equal to 2.4 pounds, okay? So I'm going to write this off to the side, so the expected value, because I'm going to have to do another type of problem, 2.4, okay? Okay, now let's go find the variance. Now you got to be careful with the variance. So the variance of large minus small is equal to the variance of the large plus the variance of the small. Now, look at here. Even though I'm subtracting, I am adding. And remember, the reason why that is because standard deviation is about the distance. It's about the distance, so it's absolute value, so we're going to add. So we just got this. So this is going to be 2.56 plus 0.81, which is 3.37. So the standard deviation of L minus S is equal to the square root of 3.37 which is 1.84 pounds. It's going to be the same thing. Now do you see why I'm going to ask you about difference? Because I want to see if you remember to add. So the standard deviation is going to be 1.84. All right, so let's talk about a word problem that I would have with this. Okay, I'm going to erase all of this. So what kind of word problem will I have? So let's say I want to know what is the probability that there's two boxes. One box has small pumpkins and one box has large pumpkins. And what is the probability that the small pumpkin is bigger than the large pumpkin? Okay, I think you can agree with me that is not likely, but it could happen. It just so could happen that I pick out the bigger of the small pumpkins, and when I put my hand in the box of large pumpkins, I picked out a small one. All right, so I want to get these all on one side of an equation. Notice here that I have L minus S, so I want to have that L, because I already did the math for this, so why do more work? So I have 0 is greater than L minus S. All right, 0 is greater than L minus S. Okay, so what's the probability that the smaller is greater than the larger? Okay, so let's go do a normal distribution. All right, my mean is 2.4. My standard deviation is 1.84, and I have 0. Okay, so this is the probability that large minus small, oops, I don't want to do that, excuse me. Okay, now I'm dyslexic, so just a second here. My point is towards the letters. It's less than 0, so I'm going to shade this way. Okay? So we're going to say that this is equal to the probability that z is less than, so let's do my z-score math. So I have 0 minus 2.4 divided by 1.84. So negative 2.4 divided by 1.84 gives me negative 1.30. Negative 1.30. Okay, so now I'm going to get out my chart. Going to look up negative 1.30, negative 1.30, and I have 0.968. All right, so that's the math that I did, and now I'm going to write my answer. My answer is a sentence. My answer is not 9.0968 or 9.68%. It is a sentence. We are now at the point where we have to write sentences. Okay? Okay, so I'm going to say there is a 9.68% chance that a small pumpkin is bigger than a large pumpkin. Okay? So hopefully that makes sense to you. If not, just come in for tutoring.